how to store images for machine vision application. MQTT protocol can be very useful for that, and that's what we're going to see today. Usually, the industrial use cases for quality control is to detect some defects using a camera, but we can also use those machine vision camera to run more advanced analytics. So either some machine learning algorithms that you will run over an entire sample of images. So in order to get that sample, you need to store, let's say, once every second, the images coming from the camera. So we can use MQTT to do that. There are multiple ways, but that's what we're going to see today. And as a first step, you need an MQTT broker. So first step is to familiarize with the MQTT protocol, but the broker is really the central piece. Usually we'll talk about some event-driven architecture where the broker is used in unified namespace architecture. Those are a kind of architecture we'll see frequently. First step will be to have a publisher, so your machine vision camera publish the images via MQTT. So in that case, once, so 1,000 images per second, so 1,000 frames per second. And what we want to do is to take a sample of that and store it once every second in an historian. So we encode those images just to make the storage simpler, and we store those images into a NoSQL database, which is mongoDB, because it's pretty useful for large document storage. We could have stopped there, but usually we add an IoT platform in the middle just to orchestrate the whole thing or to monitor and make some little adjustments. In that case, I'm using Ignition as a subscriber to that same broker. So we really have an architecture where the broker is the central piece and all the events, all the structure can come through the broker. That's really typical of the edge-driven architecture or the unified namespace. Of course, all of that is in some containers just to make it much flexible. I'm using here Docker Portainer option on it. And since I'm not using the full version of EMQX, so the enterprise edition, I'm using here the open source edition. So I don't have the connector, native connector to MongoDB. So Ignition will be the one publishing to the historian all the images once per second. If you guys are interested, I can provide a GitHub repository. So I will actually provide it, I think, down this video so that you can also download either the Python scripts or the Docker Compose file to do the same demo and see how it goes. So let's get started. We'll start with the broker and then see the publish side, the subscribe side, and the historian. Let's start with the broker. EMQX is there. So basically we have a container running, but that's our broker. It's pretty typical, as I said, inside the event-driven architectures like UNS, Unified Namespace, because it really helps to streamline all the data points, all the events, all the structure of our facilities or multiple facilities at the same time. Here it's pretty simple, but you can really use it for like millions of nodes at the same time. And inside that broker, you see all the connections. So currently we have a publisher, which is our machine vision camera, which is simulated by a Python script. And we have our subscriber, which is Ignition, and it will store the images once per second inside our historian. Once the broker is set up, then you go and configure your publisher. So the publisher is our script. Currently, it's publishing images to that broker. So a simple Python script using the parole library. And I just published like 2 pictures alternatively, just to simulate the fact that we are seeing a process live, in terms of product quality. Once we have published those images, they arrive to the broker into a topic. So we can see the topic structure here. Typically, in that case, I'm publishing to that topic, so the defect topic. And I want to subscribe to that one. To do that, I'm using Ignition as the IoT platform, and the modules that I'm using are these ones. First of all, the MQTT engine, which is required to be a subscriber to the broker, and the mongoDB connector, just to be able to historize the images to our DB. And talking about the database, here's the mongoDB database. You see here like all the images coming once every second with the timestamp. And the images are encoded, so in the base64 format. We see here the size of that historian increasing every second as well. So everything is really like streaming. So from the publisher, our camera simulated by the Python code, to the broker, which is EMQX, and we are using Ignition just to publish to the historian and have also possibility to modify or adapt our functionality. Here, we can also take a look at how the Ignition is set up in terms of subscribing and historizing. For the subscribing part, since we are subscribing to one topic only, and it is not a Sparkplug topic because we are not using here the Sparkplug standard, we need to specify inside our MQTT engine which namespace we are using. So we are not using Sparkplug B namespace, we are using a custom one, which is like this. And once you specify that and you enter the settings for your EMQX connection, you directly see all the topics in your tag structure. So in that case, it's just one topic, and you see here it's updating once every second. The sampling here, so 1 Hertz once every second, it can be done either on the IoT platform side or natively on the broker. We have multiple functionalities in MQTT brokers where you can really adapt what's the rates of each publishing, each subscribing, just to avoid some overflow of data, or it really adapts to your use case. Now that we have subscribed to it, we can, of course, we can see, just to have it as a curiosity, all the images that updates every second. You know, you can make a binding and decode that base64 string into a JPEG image. But that's just for visual purpose. But the most critical part is to historize those images that we get every second. We use a tag change script to do that. So every time this tag, so the MQTT topic to which we subscribed, every time it changes, we run that script, which is basically taking the mongoDB connector of Ignition and inserting these images into our collection. So we turn the image into a document, and we store that document into this collection. Basically, that's it. And again, if you want the script, I will publish everything in the Github repository. So basically, that's it. You take some images, you publish it to your broker, then you can subscribe to it and do what you have to do. So either store it in your historian or analyze it in your IoT platform, or you can do multiple other stuff. I think this kind of use cases with image as a format is really particular to machine vision. I'm pretty sure you guys have seen it in maybe your industrial use cases. So I'm pretty curious to see how you guys would have done it. I'm sure there are multiple ways to do that, but I would definitely want to see how you would go about doing the same thing. So very curious. Let me know what you think about that. And for those of you who discovered the channel, so this is a channel about everything related to industrial automation. So from the field level to the SCADA level, MES, IoT, data interaction. So if that's the kind of topic that's interesting for you and you want the same content but in English, let me know. I usually do my content in French, but I can also do some videos in English for you guys. All right, so stay tuned. We do some content every Tuesday. So if you want, you can come back next Tuesday. Cheers.